In this video, we are going to be talking about exponential continuous population growth within this population of frogs. So what we're given first is the N0. What is the starting population of this population of frogs? Okay, at the beginning of the season is 573 adults. Okay, so 573 adults. Collectively, these organisms have a total of 350,000 eggs. Okay, so that's the births, right? So the number of births is 350,000. Okay, ultimately, if we want to calculate the birth rate, which we're going to need here in a moment, we can put that over the initial population size. So 573 adults. So 350,000 divided by 573 is 610.82. Now, I told you to round to the nearest hundredth. Okay, so make sure that you're rounding to the nearest hundredth all the way through. So all the way through these different calculations. Okay, so what this means is that for every individual, they're contributing almost 611 individual tadpoles. Okay, so pretty impressive there. The mortality rate, I tell you that collectively, right, out of the entire population, that this many total tadpoles and adults have ultimately died. Okay, so once again, and I just want to draw your attention back to this. It's the number of deaths over the original population. Okay, so the number of deaths is 349,548 over 573, okay, for a total per capita mortality rate of 610.03. Okay, so once again, for every individual, 610 individuals die. Okay, so the per capita growth rate, which is what the question is actually asking you for, is B minus M, as we know, 610.82 minus 610.03. Okay, so these huge numbers, ultimately, it all boils down to a per capita growth rate of 0.79. And once again, rounding to the nearest hundredth here. Okay, so that is the per capita growth rate. Okay. Now, assuming exponential or continuous growth, what is the population size going to be in 5 years? So I clarify that with N5. Okay, so first of all, this is continuous exponential growth. So we want to use this set of equations here. And what we are looking for is the population size. Okay, so the population size, that is an N. Okay, now if we look in all of these different equations, we can see that we can calculate the population growth rate. Okay, we can calculate the population size, or we can calculate the time it will take to double or triple or quadruple, etc., that population size. This question is asking for the population size, so NT. Right, and this T we are going to specify is 5. Okay, so the equation we're going to use, okay, is NT, and we're going to say that's 5, is equal to the original population, 573, times E to the rate times the time. Okay, so let's plug this in. We have the original population, 573 individuals, times E to the rate, right? We just calculated the rate, 0.79, times the time. And once again, we want time to be 5 years. Okay, so I'm actually going to type this into the calculator because of the exponents here, just to make sure that we're all on the same page. Okay, hopefully we can see without too much glare here. There we go. So we want 573 times E. And note that the E automatically puts the parentheses there. This isn't the case on every calculator, but 0.79 times 5, and we'll close the parentheses here, and that gives us 29,758 and change. So The size of the population in 5 years, assuming that this growth rate stays the same and there's no limits, right? It's exponential growth, not logistic. The total population size is 29,758.97. I, of course, tell you to round to the nearest whole number. Okay, and that's going to be important because, of course, you can't have 0.97 of a frog. So technically, this would round up to 59. Okay. Finally, the question is asking you for how long will it take, right? How many years is it going to take for the population to be 10 times the size? Again, assuming exponential or continuous growth. And so for that, we would use this equation right here. How much time, right? Not the size. We know the size. We are asking about the size. The time it would take to, in this case, increase tenfold. Okay, so for this last part, t, how much time would it take to be 10 times as large? Okay. So we would use the natural log of 10 over the rate. Okay, in this case, the rate is 0.79. And so if you put this into the calculator, ultimately you are going to get 2.9 years. Okay, again, I tell you to round to the 10th, okay, not to the 100th, which would be 2.91. It's 2.9 years because I tell you where to round. Okay, again, years is the units because t is what we're looking for, time. The number of individuals, so this would be individuals in 5 years. Okay, and so on and so forth. So hopefully that clarified that seemingly tricky question for you guys. Thanks.